let's talk about hypochlorous acid has a Ka of 3.5 times 10 to the minus 8th. So I want you to calculate the pH of 0.1 molar aqueous solution of hypochlorous acid. This is something you're going to be asked to do on the AP exam, and so you need to understand what's going on here. So 0.1 molar solution of hypochlorous acid with a PA or a Ka of 3.5 times 10 to the minus 8th. Here we go. List the major species. Who are going to be the major species in this case? So hypochlorous acid is going to be H plus and OCl minus. Are we okay with that? Plus H2O. That's going to be in there. This is a weak acid and remains mostly undissociated. We're actually going to have the HOCl and H2O. So when we were looking at HCl earlier, HCl is a what kind of acid? HCl, hydrochloric acid, is a strong acid. Strong acids do what? Completely dissociate. This is a weak acid. Does not completely dissociate. This is going to dominate over the two particles we just talked about. You're going to need to consider those two particles, but in terms of major species, they're right. This is HOCl and H2O. The undissociated acid and, of course, water. Both of these can produce hydrogen. So y'all should sketch these out. This is what you would do here. If we're looking at HCl, really your dominant producer is going to be the HCl, and you're going to look at how much you have. Good? Oh yeah, looking at these numbers, Ka versus the Kw, which one's going to be stronger? This is a significantly stronger than acid. It's going to dominate in the production of the hydrogen ions. So it's the one we're going to consider. This is my equilibrium expression. Good? All right. The initial concentrations. We initially started out with this, right? We have 0 of this, and we're going to ignore how much is coming from water. Because compared to however much we're going to get from the hypochlorous acid, it's really, really small. All right, good. System's going to reach equilibrium by some amount of dissociation, so we're going to let X be the amount that dissociates. So we're going to rewrite this. Now, how much of that's going to dissociate? A lot or little, because it's what?
Weak acid.
Weak acid. There we go. We're getting there. All right. This is going to equal this. This is also going to equal this. We're going to assume that we didn't really add anything. We're going to assume we basically started with 0. So these are each going to be X.
Do we typically assume it starts at 0 if it doesn't tell us otherwise?
The hydrogen ion?
Yeah.
Depends. You're going to have to look, and I'm going to suggest to you yes, because if it's really weak, like that example we used last class where it was very dilute hydrochloric acid, then that was kind of a weird example just to point out. It has to give you more hydrogen ions than water. Otherwise, the water is going to dominate the production. The pH is going to be 7. Make sense? If I just add a few hydrogen ions to a container of water, that's not changing enough of the ratio, enough of the hydrogen ion concentration. Enough of the hydrogen ion concentration to affect the pH at all. So that's what you need to be worried about. But yeah, assuming it starts at 0 is a reasonable assumption. All right. There to go. And we're going to make this crazy assumption that very little X is going to be subtracted. That's going to make our life super easy, right? Again, this should all be very, 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 very familiar. So hopefully by now you can go ahead and crank this out and solve. Because you can figure out the hydrogen ion concentration, and once you do that, then you can find the pH. Lunch. Donuts and animal crackers. All right. We good here? Okay. So we found that X is 5.9 times 10 to the minus fifth. That's my hydrogen ion concentration. Can you take that number now and get to pH?
Yes.
Okay. Is that what you got? You look a little.
Confused on how you get 4.23.
So yeah, remember pH is the negative log of the hydrogen ion concentration.
And then we're saying pH should be the negative log of
Hydroxide ion concentration, yeah. And pKa, like we learned last class, is the negative log of the Ka. Everybody okay? All right.
Wait, what was that with the, you said POH was negative log of Ka?
No. POH is the negative log of the hydroxide ion concentration. pKa is the negative log of the Ka. Yeah, we learned that last class. Okay. What are the major species present in 0.25 molar solutions of each of these following acids? So, first of all, what do we know about that guy?
What guy?
This guy. Strong or weak?
Weak.
Weak. Why?
Because it's not strong.
It's not strong.
Wait, am I right?
I can assume
Yeah.
it's also weak.
Yeah.
Next test, 100. Wait, do I take the back? How does that work?
You unknock?
If you knock, that means it won't happen.
Yeah.
Maybe you should
Okay.
say something
If
bad.
you knock on wood, like, oh, I'm gonna die.
All right, so here we go.
Yeah.
Then you, wait, and then make sure I do that. I does wait.
Yeah. Y'all ready for this?
No.
All right, here we go. You'd have to have the data for that. So anyway, we're going to keep going. Let's do this one.
That makes more sense.
This is what you have to have. Yeah, you would have had to have had the you'd had to have the information. But here we go. Calculate the pH of a solution that contains 1 molar hydrocyanic acid and 5 molar. What is that?
Same thing.
Hypo.
Just nitrous acid, right?
Yeah, nitrogen.
Nitrous acid. Because HNO3 would be nitric acid, right?
Yes.
So this is nitrous acid.
Because there's one left.
Uh-huh. So let's look at this. I've got a, first of all, look, and while we're at it, we're going to add another little bit of fun. I want you to figure out how much cyanide is going to be present in this solution. How much cyanide? So first of all, let's look at the Kas. Notice the difference on the Kas. But notice this is a 1 molar and this is a 5 molar. So notice that information. Let's attack this process from a thought perspective. These guys are going to break down, pardon me here, what's going to be the dominant species or who's going to be the big contributor of hydrogen ions?
The first no.
Second one.
The second
Second one by what?
By what?
Well, probably a lot.
Probably a lot. All right, well, let's start. Y'all ready? Yeah, you may need more space, and this problem's in your notes, right? You may actually need more space on a piece of notebook paper to write through this one. This one actually is very useful because it's going to be a common ion issue, because we're going to be producing a bunch of hydrogen ions, but those hydrogen ions are going to drive this situation. It's going to affect that. So you've got a couple different thoughts here going on. Song almost as old as I am. Good. Both weak acids, mostly undissociated. That means the major species are just going to be hydrocyanic acid, nitrous acid, and water. Those are going to be your big players. Right? So the next question is, well, who's going to be contributing the hydrogen ions to this mix? Okay? All three of them are going to produce hydrogen ions. There's your three different equations. Now, obviously, you're not going to be doing this every single time because you could pretty well easily tell from the original data who's going to be your primary, right? Jess, you need a paper?
No.
Okay.
Thank you, though. I might have a little bit, but I have some.
All right. So based on this, who's going to dominate? Yeah, I would think so. If I tried to do all three of these at once, it could be an issue. However, as we just pointed out, the nitrous acid is going to be the weak acid, much stronger than the other two. And as far as I can remember, all of your problems are going to have one clear-cut winner, and you're going to go with that one. Okay? So we're going to just ignore the contributions of hydrogen ions from the other two. We're simply going to consider the contribution of hydrogen ions from the nitrous acid. Here you go. Yes, my wonderful Yep, we're lovely back down to 66 Fahrenheit in the classroom.
How much in Celsius?
I think it's 18. Maybe 19. I'll push the button and find out.
I think that would be 19.
Yeah, it's 19. 68's 20, so yeah. I want a Kelvin thermometer. Like, no, I'm gonna have to start making them and selling them on Amazon or something. I want to.
Probably make a lot of money doing that somehow.
I have looked all over Amazon for them. And I can't find a Kelvin thermometer. I just think it would be really fun. Apparently. All right, y'all good? So you're set up your little table like this, your little rice table. 5.0 minus x, but what are we gonna do with x in this case? We're gonna ignore it because it makes our life complicated. And it's always good to ignore things that make your life complicated, right?
Yep. My go-to.
Yeah.
Like I did last semester. I can't find it on Amazon.
Okay, that's not a nice wall thermometer.
Oh, like you want?
Yeah, I know I can get a probe, but I want something I can hang on the wall just so that when we come to this thing in chemistry, I can just point to it.
I'm on this website and I found some fun things. They're kind of confusing.
Okay, so here's our little table,
I give up.
right? I'm going to tell you, you don't need to use the 5% rule on FRQs, and it's the only time you can do this, right? Because if it's presented to you, it's not going to need quadratic, and if it doesn't need quadratic, it means you can ignore it. Y'all follow me? I know this book keeps telling you to test it, and in the real world, you might have to do that, but, you know, yeah, which AP is not real world, okay? Yep. Okay. Good enough. But so is life, so that's okay.
Good point.
We also have fun on the side.
Hey, got it.
Did you get it?
Mm-hmm.
How about that?
I got the pH.
Good? So did you get the pH?
Yes.
All right. So this is one of these cool little problems here. So the pH is 1.35, right? But this is a weak acid. But people might say it's a weak acid. How on earth does a weak acid have a pH of 1.35? What's the flaw in the logic? Many, many students have this, starting with my little babies. What's the flaw in the logic thinking about a weak acid having a pH of 1.35? Anybody know yet?
I would assume part of it is because it's in a solution. Generally speaking, throw quite a bit in there. If you throw a little bit of hydrochloric acid, then it's going to end up probably being less than what a weak acid would be.
It's a little more fundamental than that. What's going on?
It's also the fact that the pH doesn't really matter.
Okay. What's the definition of a strong acid? Dissociates completely. Okay. Does strong or weak have to do with pH? No. Concentration of hydrogen ions is what has to do with pH. In this case, we've got a 5 molar solution of a weak acid. So yes, it's a weak acid. It's not going to fall apart completely. But it is going to fall apart enough. And I have 5 molar. It's fairly concentrated. Okay? So I can still have a pH of 1.35. Whatever this is, you probably still don't want to drink it or get it in your eyes or get it on your skin. This would be a bad experience. Okay? So just because it's a weak acid doesn't mean it's safe. What it means is it doesn't fall apart completely. Sense? All right. Now, for the fun part. I've got a whole bunch of hydrogen ions in here. How is that going to affect the equilibrium of the cyanide ions? Okay. The only place cyanide ions are coming from is from dissociation of a hydrocyanic acid.
Yeah.
Follow me? It's the only place cyanide can come from. What's that? So let's think about that, though. The hydrogen, on the other hand, what's going to be the dominant source of hydrogen ions? The nitrous acid. So if we're going to ignore everybody else like we did here, we can do the same thing. We can just say, look, we're going to start out with this much hydrogen ion. I'm going to ignore the hydrogen ions that come from water. I'm going to ignore the hydrogen ions that might come from dissociation of the hydrocyanic acid. So let's do that. Here's our dissociation. Okay? We know this dissociates very, very weakly. Okay, based on the numbers we have. So we're just going to think about dissociation of the hydrocyanic acid to figure out that. Okay? Here's our equilibrium expression. Well, that's why I teach it in the order I do. Okay? So did y'all solve it? You get it yet? So set up a rice table. What's the X going to be? I don't care where the hydrogen came from. We're just going to go ahead and assume that that's all the hydrogen we have.
2.489997 times 10.
Okay. This is 1 molar. This is going to be really, really small. So we're going to say that however much dissociates, we're going to ignore it again. We're going to put our equilibrium expression here. Where's our equilibrium expression? There it is. Instead of H here, I'm going to put the number from the whatever that was, that previous.
Oh, 4.5?
Yeah, this one.
Okay.
That's going in the spot of the H. That's what that text just said.
What?
Okay.
Because that's where the hydrogen ion comes from.
Yeah.
Remember, that's like the
X?
the nitrous acid.
Oh.
The nitrous acid is what's making all the hydrogen.
There you go.
So because they're all in the same container, it would basically everything else doesn't really matter because they're producing so little that they would just cancel them out anyway.
So you use the 0.0447?
4.5 times 10 to the 6, the hydrogen concentration.
Yeah, it's the same value. Yeah, the hydrogen ion concentration that you just got finished calculating from the dominant contributor. That was a perfect explanation given right there. That's exactly what's going on. Your X, this is your X here. So remember last time we had an X and an X. Well, we know this one, so we don't need an X. We're going to plug that in there. And we also know they're not going to be the same.
0.04, yeah.
And we know this one because it's the similarity, right? There it is. So there's our new equilibrium expression. That's what we were just saying. And now you just need to plug it in your little calculators and solve for the X, the cyanide concentration. What'd you get?
1.38 times 10 to the negative 8.
Is that what you got?
I got 1.39, but yeah.
Cool. We good?
Yes.
See how easy these problems are?
It's easy
So
when
nice.
you do it in class.
Okay. So if you'll go home tonight and do it, because you've got nothing else to do,
Oh, no.
you have chemistry.
When you forget about the physics test and the Jones
None of that other stuff matters.
Yeah, like the English essays. I've had them all.
Well, the English essay you've had a month to do, so I figured that was.
We finished the book like last week.
Why wouldn't you have us read the book in class then? Why
Yeah.
wouldn't you have us read on our own time?
Like
Because
we
we all
finished
finished
it.
and then she's like, all right, now here's your essay immediately.
Yes.
We didn't have time to research the book, we're still reading.
Okay, but you should have read the book ahead of time, and that reading in class was just for fun.
Reading in class is time to do
That was
more
like the
homework.
best essay I've ever done, and I did it in 3 hours.
There you go.
That happens.
That happened.
You're at your best whenever you cut the time.
Exactly. I got probably 7 of them.
Well, good. I'm hoping May 7th some of y'all will be at your best.
Yeah, I got that.
I submitted
It's
my
a hope.
essay at 11:50. 11:55.
I didn't have the but I did have a test.
But I'm still taking the test.
I want to exempt all my tests. I don't want to do it.
I'm exempting mine.
We don't have any tests.
Are we still doing the project?
Yeah.
Any thoughts on
Music
what it's
video.
gonna be?
Yeah, no, actually I have. It's actually a science useful thing. So for those of you who are not, which is only you, the rest of y'all, so I'd like y'all to work on, I have your 9 weeks test is something you should be able to get 100 on. So I need to get that assignment put together. That is like on my list. I mean, I got to get a few grades put in for y'all, a few real grades. But so y'all can have a real grade instead of 110 like some of you have.
Who?
Can't wait to see that.
It's from the extra credit.
Yeah.
There's extra credit.
Think about.
So
That's gonna put it away.
good, very nice. I'm proud of you.
Do you want to?
Have you read it? No, because you haven't read it. I can tell by the edges of the pages. I know you have. I can see. You've taken care of it.
I don't have close thinking notes, but I read it.
Okay. So here's. So I'll be explaining that and posting that. But yeah. So your 9 weeks test should be an easy 100, but it's going to be time consuming. Okay. The final exam will be y'all doing labs. So I'll probably put you in probably pairs. So one can video and one can whatever. Okay. You'll have to do nice explanations, and y'all can self-select, whatever. But you'll come in here at some point, plan your lab, do your lab. I'll have a kind of like the English people do. I'll have a list, open it up at 7 o'clock in the morning or whatever, and y'all have to come and circle the lab you're doing.
That's fine.
And again, you'll present it. You'll take pictures of the measurements. The idea here is that someone who is unable to physically do the lab could watch the lab and get that experience, or if it's a lab that has to get cut for some reason. So we're actually going to have y'all will be doing some labs, and that will be we'll do this probably in class after the AP exam. And so we can have 2 or 3 different labs going simultaneously, but your grade will be basically how well you do it. Yeah?
Can we put music behind it?
In spots, and then I want you to have spots that aren't. Obviously, it has to be appropriate music, and I don't want the music playing while you're talking. So, like when you talk, the music needs to cut. So,
What about Sledgehammer? Right, Peter Gabriel.
so anyway, we'll talk about the details of that. But that's going to be your final, because most of my seniors are going to exempt. Well, you got to have an 80 to exempt, so maybe most of my seniors are not going to exempt. Anyway,
80 to exempt?
yeah,
Like, everybody?
no, just seniors.
Oh.
Wait,
That's
that's not fair.
away exempt.
Wait, it's 80 for
Huh?
Remember Dr. Levesque did away with the.
No, Mr. Thetford said that we
You can exempt. You can. I think you can exempt one exam or maybe two.
It was only seniors.
No, everyone else gets 2. Seniors can
Oh,
exempt.
It's 2. Okay.
Yeah.
yes.
Wait, so you
Seniors
need
can like
to
exempt all their classes, but we can
Basically,
only.
I'm going to have one final in this class.
But what grade do we have to have?
80.
But it can't
80?
be like an 85.
I thought it was an
Same, less.
85. Did they change it?
Something like that. I forgot.
But
No,
I think
English. No, English.
I know. It's like.
What's the point?
All right. Good. So do you have this concept down?
Sort. Oh,
All right.
Yeah.
You get 0 if you're wrong.
Let's talk about percent dissociation. Percent dissociation a little bit. All right. It's simply the amount dissociated divided by the initial concentration. It's not a big, hard concept here. Okay. I need to.
The grade you got over the grade you wish you got.
For a solution of any weak acid, the hydrogen ion concentration decreases as this decreases. The percent dissociation increases as this decreases. All right. What is the percent dissociation of acetic acid in 1 molar acetic acid? That's my Ka. Let's calculate percent dissociation. Good? Acetic acid, much stronger than water. Thus, the dominant equilibrium will be what? Write it down. The dissociation of acetic acid. Yeah, that's it. There's my equilibrium expression, as one might expect. The one thing I will notice that I think is important for you to notice that's different than the salts is that there is a bottom number. Somebody mentioned this. And why is there a bottom number?
Because this is aqueous.
Because this is aqueous. Remember, with the salts, we were starting out typically with something that was solid.
You don't include solid
And so you don't include solids, liquids. Exactly. Somebody asked that to me after class, and that's why I want to make sure you guys catch that. A little bit different than when we're doing the salts.
Are we solving for the total or theoretical right now?
Percent dissociation.
Well, yeah, but like we don't know what the theoretical yield would be.
Well, no, first you calculate it and it's over the...
No, it's just,
initial.
it's however much is dissociated divided by the initial.
Oh, okay, that makes more sense.
Yeah, this is not percent yield. This is percent dissociation.
I was kind of thinking like percent yield.
Yeah. All right, everybody got to that point? Throw in your rice tables. Punchy, punchy. Fun, fun, fun. Just like a high kick.
Well, no.
Those are not fun.
Got it.
Good?
Yeah.
I feel like I did it.
You got your little table?
Yes.
Throw some punchy, punchy in there. Again, we're going to ignore this x because it makes our life difficult. It's always good to ignore things that make your life difficult. Actually, it's not entirely true. You should do the absolute opposite of that. You should always face your demons and slay them. There you go.
Pretty cool.
Slay them.
I'd rather
You'd rather run away?
I'd rather sleep.
Sleep.
For sure.
Yeah, me too. Sometimes they find you then too.
Got a total 2 hours of sleep.
They really do.
So I too would rather sleep.
I've had the weirdest dreams.
About what,
I
Jaime?
question.
No, like,
About what?
like someone like watching me. Like,
What?
but
No,
I'm like half
no.
asleep. It's so weird.
You know the Scream guy? Have you ever seen the movie Scream? She's
Yeah.
I genuinely question how I cannot be able to sleep all the way through 5, but then end up falling asleep and I hit the snooze button on my alarm. So annoying.
Yeah.
That happened today. I'm like really tired now.
So did y'all get that?
Yes.
Easy, right?
Yeah.
So how much dissociated? So what was the percent?
0.42.
Boo! Look at you. You know how to read answers.
Wait, so it's just getting the
No, look,
answer.
I did it.
Oh, you actually did it too. Okay.
I did
What's
it.
that?
Just
Once in a
getting
while.
the answer
Good
and
job,
then
Jeff. Thank you.
multiplying it by 100.
This is
Well, in this case, the 1 was on the bottom. You'd have to look at whatever was in the bottom, right? Whatever your initial concentration was. That's how much ended up becoming hydrogen ions, and that's how much your initial acid was. So this is a 0.42% dissociation.
So if the bottom was 2, then it would.
Yeah, 0.21%.
Alright.
Oh, come on.
Is your tick not talking?
It's English. What? I got a 75 on the last time.
Ouch!
And now I have an 85 in class.
Ooh.
Am I just having a good grade in English?
All right. Now let's think about this. I want you to use this dude's principle to explain why percent dissociation increases as the concentration of the weak acid decreases.
Wait a minute, I think I remember this principle.
So the Chatelier was saying, right, if you have something that's at equilibrium and you disturb it,
It will go back to you.
it's going to do something. It's going to do something to go back to equilibrium. It really wants to be back at equilibrium. So when you disturb it, what's it going to do?
It's going to shift the reaction.
Right.
Yeah.
All right. Here we go.
I wanna be sledgehammer.
I think that song's older than you too. All right. What's going to happen? Dilution shifting the equilibrium to the side with the greatest number of particles. Okay, so percent dissociation will increase. Cool. All right, let's go backwards. Let's go backwards. We can calculate percent dissociation from Ka and concentration. We can also calculate Ka from percent dissociation. So here's lactic acid. Some of y'all may have experienced the fun feeling of lactic acid. In a oh, that's right. You're in athletics.
Yeah.
Yeah.
I got
No,
3 ejections in my last game in the
Yeah.
second quarter.
Yeah,
Because
lactate.
they played me at the top position, and I've never played there before. I'm like, just play the person who knows what he's doing, please. And it's like, you got this.
Yeah.
I ain't got this. But I mean, I got to go to storm practice after, so I'm
Well, there you go. That's fun. That's why. So if you'll do a cool down, that will help flush the lactic acid out. If you do a really hard workout and then just collapse, you're probably going to hurt the next day.
the day after that, the
Like
day after
jumping
that,
jacks?
the day after.
No, just go. What do you mean by cool down? Like sitting in a bathtub?
You basically
No,
do the
like-
thing you were
like-
doing, but like 100 times
Less. Yeah. So keep doing what you're doing. Just dial it way down.
Oh.
Imagine doing that.
So like if you're running,
Oh no.
walk a lap around the, that kind of stuff. And it's not going to get rid of all of it, but it'll get rid of a lot of it. All right. Anyway, in a 0.1 molar aqueous solution, lactic acid is 3.7% dissociated. Based on that, let's calculate the value of Ka. So if I know it's 3.7% dissociated, I should be able to figure out how many hydrogen ions I have, right? Huh.
Hold on. I'm just going to do this.
Why won't you just go with, there we go.
Excuse me.
Oh, negative.
Yeah, other direction. But yeah. I know I went to all that I would have started here. Exactly where we all started, right? Just to figure out that.
Why? Oh, never mind.
Wait, can't we just...
This gets us our hydrogen ion concentration, right?
Yes,
Okay.
but doesn't it also do...
That tells us X.
Yeah, so... Yeah, okay.
Easy.
So we got to there, right? Everybody got to here, yes?
Yes.
Everybody's here? All right, cool. Now I can use that to calculate Ka. 3.7. In this case, the reason we have to write that, right? We've got to know the hydrogen ion and the acetate,
Okay, good.
and we just plug it in. But yeah, go ahead and take a second and write all this down. What?
Huh?
What?
Nothing.
Okay. So 1.4 times 10 to the minus fourth. Sounds good?
Yes.
Fantastic. All right. Let's look at the major species in the solution. Look for the reactions that can be assumed to go to completion. Acid-base problems. This is what we're doing now. We're moving on to acid-base problems. For a reaction that can be assumed to go to completion, Easy enough. We're going to determine the concentration of the products, write down the major species. Okay. We're going to look at each of the major components. We're going to pick the equilibrium that gets to control the pH. That's the one we care about, the one that controls the pH. We're going to use known values when we have them. We're going to figure out the dominant equilibrium, write the equations, and move on. We're then going to compute the initial concentrations. We're going to assume that the equilibrium hasn't happened yet. Then we're going to define X, compute the equilibrium concentrations in terms of X, substitute the concentrations, check validity. Well, we're not really going to do that. We're going to calculate the pH and other concentrations as the problem requires. What do I mean? A 0.15 molar solution of a weak acid is 3% dissociated. Calculate Ka. You know how to do this. Please do that. We just did an example of that. That's a good seating chart.
What is?
How y'all are sitting now? I think I'm going to have to change that.
There is a
Does
seating
you have
chart?
to change that?
Yeah.
You just
I like
folded
this
a
one.
diff- Oh, wait. Darn it. I just didn't.
Change my old, yeah.
You would sit on that stool.
I get that now.
Wait, which stool? Oh, that one over there. I thought you were talking about like this. You can see it. It's like a really.
I think
tiny-
that one over there by the door,
Yeah.
Yeah.
You'd be like the guard.
the guard.
Exactly.
Oh.
Oh, yeah, why
You
is it
throw
there?
Altoids at him.
Stay there. Stay.
I guess I should mark him absent, I guess.
Okay. I don't know. There's coffee in my
Being
bag.
absent, would never be the same. There's no online.
No,
Huh?
no.
It's like all online. So people are teachers are just gonna put it online, like I can do it online.
Nope.
You know what? I'm just gonna.
Uh,
think this is right. I'm not sure.
I think I'm going to go back to the old days with stone tablets. Y'all going to have to etch your notes by hand.
Aaron is on TikTok.
Everybody got your KA?
I believe so.
Who is?
Yes. Aaron is on TikTok.
Live?
Look.
Oh, just playing. Yeah. Everybody got KA? What'd you get?
1.35 times 10 to the negative 4.
I would agree with you.
Really? I'm a genius. Today.
Tomorrow.
No.
Tomorrow's another story.
The amount of street right now.
Tomorrow's another day.
Well, tomorrow I'm not gonna be doing anything.
Oh, is it?
I'm
You
working.
better be doing some AP chemistry tomorrow.
Well, yeah, when I'm not getting people from class to donate blood.
Yeah.
Oh. Wait, are you missing all this?
Yep.
Do you get to do the blood?
Really? Again? Hello?
Yeah. We do know how to do it.
No? All right. We don't have Madison in here, do we? No.
I did something wrong.
Which maps?
Exactly.
Do you want to see how many times Aaron opens TikTok?
What is the major species in an aqueous solution of hydrofluoric acid?
I feel like I know this one now.
Hey, the Ka value for hydrofluoric acid, 7.2 times 10 to the minus fourth. What is it? Major species. Who's the big players?
You got that.
H2O. H plus
B.
N.
So
F.
does B. It's not B.
It's not B.
What if it's E?
No, wait. H.
Yes, it is. So follow that up.
It's E.
It's E. Good job.
What?
Okay.
So it's a weak acid.
Oh.
So when I look at the equilibrium of HF,
That's right. Oh my gosh. We literally did it earlier.
right? So we literally did this earlier, right? Most of this sits here, just like with H2O. right? Most of it sits here. Now, if it was HCl, most of it sits here.
So if it's greater than 1, it'll be.
Yeah, it's over there.
Let's do this one. Some more.
All right, let's try another one. Let's see a fun little graph.
Ooh, fun graph.
Which of the following best represents a plot of hydrogen ions versus the acid for a weak acid at a constant temperature?
C.
No. I say B. I'm feeling B.
The answer can't
think
be
it's
C.
B. Wait.
The answer can't be D either.
So it
Or
can't be C.
It's B.
Explain your logic.
Well, because for a weak acid, most of it is gonna be the HA, and
Mhm.
as you get more of that, you're gonna have less of the hydrogen ions. There's not gonna be much of an increase there because the weak acid, most of it's the HA.
That's it. Bingo.
Because weak acids don't dissociate
Weak acids don't dissociate
as much.
as much.
So that's why that's the little curve there.
I
Uh-huh.
just looked at the graphs and realized that almost none of them went to 0, 0.
Right. As a
Hydrogen, so
as a relationship between the two, right? That's what we're talking about.
yeah.
Okay. If I have very, very little of this, I'm going to have very, very little of that until I get to a certain point where I'm not increasing that. Cool. All right. The percent ionization for a 4 molar weak acid is blank the percent ionization for an 8 molar weak acid.
Greater.
More dilute, greater percent. Beautiful. I know that's a tough one to wrap your brain around.
Well, because like if you think about like it's like a fraction.
Yeah, I just
The
thought
bottom
it was
number,
fraction. If you
yeah.
have a lower number, then it's gonna be.
Yeah, I just
If you
put
have a
10
bigger number on the
because
bottom,
that-
it's too high.
1/8
A
is
10
bigger
over
than
4.
1/12.
10 over 8. 10 over 4 is bigger.
Okay.
It works.
All right. The pH for a 4 molar weak acid is what about the pH of an 8 molar weak acid?
We're talking about the same gas, right?
Negative log of hydrogen ion,
Oh.
the concentration.
Bigger. Less than.
Greater.
Less than.
Less than. Oh, less than, yeah, 'cause pH.
Because it takes a negative log of that. And then. Yes.
Right? I'm
Yes.
right? It doesn't matter?
Yes. 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 Yes.
Because greater means what?
Bigger.
Yeah,
More
it's-
basic.
Oh.
Fewer ions, right? If I have the pH of a 4 molar weak acid has fewer hydrogen ions
Oh.
than an 8 molar.
Okay.
Therefore, the pH is going to be higher.
What?
Remember, pH goes up as hydrogen ion concentration goes down.
It's a negative log.
Yeah, this is actually something I'm talking about with the babies again, because we've got to get that into y'all's head. And it's got to be like really an automatic process, because under the stress of a test, your functions are not going to catch that. Okay. All right. Let's now talk about bases. The cool thing is, now that y'all have mastered acids, okay,
Bases aren't the
you're done dropping acid. Now you can drop the base.
I get it. That's a funny pause.
Wait, say that again?
You're so funny.
Something about dropping bases.
All right.
Ooh, someone-
Completely.
Oh yeah.
Did really?
Literal base?
Yeah,
Yeah.
that part of the right, it's called
Yeah.
the nut, right? Part of the nut like broke off.
The scroll, not the nut.
Oh.
The
Oh.
scroll, the top, the scroll, the top.
Ah, okay.
There
Like
are
an
no
actual base
nuts on the front.
Yeah, it's the thing.
There are tuning pegs.
No, the nut's like that one part.
Okay.
Oh, the little.
Strong bases completely dissociate.
I thought it was
Strong bases completely dissociate. The hydroxides of the group 1s and most of the group 2s. Do you remember the eight strong bases?
This.
It's on my reference sheet.
Yeah. So it starts with lithium. Get your periodic table. You go lithium, sodium, potassium, rubidium, cesium, over, barium, strontium, calcium.
What?
Yep.
Lithium, nitrogen.
It's just that.
Yeah, it's this.
7.
8.
Lithium to cesium variant.
Lithium, cesium variant. Lithium, sodium,
Acids
potassium,
are just
rubidium,
simple.
cesium variant.
Yeah.
calcium, calcium.
Yeah.
I just look at them, and sometimes just by looking at them, just for some reason I know if it's strong enough.
Good. All right.
Good.
Just subconsciously I know.
So I think your book considers magnesium hydroxide. I don't, and I don't think the rest of the world does either. But
What does it book do?
yeah. So, and there's actually some debate about calcium hydroxide. Calcium hydroxide takes a second to get dissolved, but you have like a sweater on and long sleeves. All right. There's calcium hydroxide. Possesses a low solubility. This is why there's some discussion here. Low solubility means it's hard to get into solution, but once you do get into solution, dissociates completely. This is not what we're used to. We're used to taking that little salt packet, pouring it in there, boom, it's all dissociated, right? This is not what happens here. So when we say it has low solubility, that's its ability to get into a solution as soon as it does. As soon as it does, right? All right. And we don't really care what we're doing with it. Calculate the pH of a 5.0 times 10 to the minus 2 molar sodium hydroxide solution. Okay. What do I know about sodium hydroxide? It's a
Strong.
strong base. We just went over it. Strong base, right? Lithium, sodium's right there. It's a strong base. That means we're going to assume it does what? Dissociates completely. That means we get to do something real fun. We get to assume that what? The molarity of that is also concentration of hydroxide. So we're going to say that NaOH completely goes to here. Okay? That means if this is that concentration, it's also that concentration.
So it doesn't have like cool arrows?
Well, it does, but I drew this intentionally to show you it's strong, and it just goes that way.
Oh.
Okay? When this dissociates, all of the sodium hydroxide turns into either sodium or hydroxide plus the water. Okay? Yes, autoionization of water is going to produce a few hydroxide ions, but not many. So the pH is going to be dominated by the hydroxide ions. Thus, in the solution, we're just going to say what I just said, that hydroxide is going to have the same concentration as the original base. And that's true for strong bases. And so we can calculate that out. Now, y'all probably remember calculating, well, not y'all, because y'all were lazy. You calculated, well, I don't know, there's somebody, you might have actually done some work. Okay? You could have calculated this based on the POH and then subtracted from 14. This is the math that goes on. If you remember that KW equals H plus OH minus, right? If I know that, and we always know that because it's a constant.
1 times 10 to the negative 14.
There you go. I can solve for that, yes? Bingo. All you got to do is make that happen. Everybody okay with that? When I do that, I find that the hydrogen ion concentration is 2.0 times 10 to the minus 13th. That means that this is going to be a basic solution because the hydroxide ion is much greater than the hydrogen ion, and therefore the pH will be much larger than 7.
Will there ever be a situation where we'll be given hydrogen and hydroxide concentration? And probably not, now that I think of it. So it would all just trickle in water.
So your pH at 12.7. Hey, multiple choice. If this number is not 1, you should look at that and realize that that's going to be 1 less than that. Notice that's always going to be the case. If this is not 1, this number, instead of, if you take the absolute value or the negative of it, that's going to be 12. You may not know what that is, but you can at least know what that is. So you can eliminate, quick and dirty, you can eliminate answers. Okay, all right. The added OH from the salt has shifted the water ionization equilibrium to the left, which is going to lower that. So what I've done here is I've significantly increased the OH here, and Le Chatelier's principle says that this reaction pushes back this way. When it does that, this is going to significantly lower the hydrogen ion concentration. Okay? Good? When a base reacts with water, they form hydroxide ions, okay? And so that's a base. That's the Bronsted-Lowry definition, right? We don't have to worry about Arrhenius because there's a lot of stuff that acts like bases, like ammonia acts like a base because it takes away a proton. All right, here's our general reaction. This is going to read, hopefully y'all have read the chapter, you've done your outline, your reading guide. All this stuff, everywhere we say KB, it's the same thing for KA. All the math is the same, all the calculations are the same, the thought processes are the same. It's just hydroxide instead of hydrogen. And we're going to call it KB instead of KA. Do be careful because sometimes we're going to give you information that's, I'm going blah, blah, blah about this weak base, and I'm going to ask you to calculate pH, or I'm going to ask you to calculate the Ka. But I'm talking about a weak base, so you're going to have to keep that in mind. But all the Kb stuff, it's all the same, which is all the same as the stuff we've been doing. All right. Let's calculate the pH of a 1 molar solution of methylamine. Okay, has a Kb of 4.38 times 10 to the minus 4th.
Yeah, there's a huge convention in there.
There's what?
A huge convention in there.
Well, I wish you would have said something when you came back.
Oh, I'm sorry.
All right, y'all solve that real quick.
It's so disgusting.
Just
Why?
Hang out somewhere, you.
what do we got?
You know what Emma is doing right now? She's watching TV. She's eating cereal. She's watching a TV show.
Imagine
You live?
time to watch TV.
For real?
No, they're on Snapchat. She's watching I don't know what this is.
Call her.
She's watching Dance Mom.
You need to call her and tell her that she needs to be doing chemistry because there's no excuses. All right.
I'm like, I can't.
Here's our major species, right? Both of these are bases, okay, but we're going to neglect water, as you should always neglect water. Okay?
Wait, hold on, pause.
Tell me to FaceTime.
What?
Tell her to do it again.
Yeah, sure.
Hello?
Get to work. Why aren't you working? You should be doing chemistry, not playing. No, no dance, moms. Chemistry. I have chemistry videos recorded for you to watch.
She's eating nuggets for context.
Okay. All right, here we go. KB 4.38 times 10 to the minus 4th. Here we go.
What? I can't see it.
I'll do like a POV chemistry. POV Jessica.
There we go. Okay. Y'all ready to go?
Sure.
This is KB. It's just like KA, just like you've learned last class.
Yeah.
And so the day you get back, we having a test.
Are we actually?
Whatever day that is. There we go. Set up your rice tables. What do I know about this X? What do I know about this X? I don't care about it. I'm going to ignore it because it makes my life difficult. Insignificant. It is inconvenient, though. I agree. It's really inconvenient. I totally agree with that.
It's a minor inconvenience.
Yeah. Okay.
A temporary setback.
Temporary setback. All right.
Momentary loss.
Where's the room?
Barbie.
Turn upside down.
Oh,
It's in the bottom.
see, I don't.
There you go. Good? All right. Can y'all do that?
The answer.
You got the answers?
You got the answer?
I hope so.
Oh, I did.
Maybe bad if I didn't.
What question are we on?
We are on the
16.
table. I'm on page probably 100 at this point. I have a second folder at home with all.
Page 16,
The methylamine.
methylamine.
Oh.
That's fun to say.
I was doing them all on notebook paper, just for the heck of it.
The cake.
Good? So now you guys are all set to do your homework that covers KB. We'll get some more homework posted so you're not bored. We'll also get some quizzes posted.
Who do you think you are? Why?
And
Why?
we could do some Quest.
No. Like, literally. Give
I
us
don't
like more
even know what
homework.
Quest
Don't
is,
give
and I
us
don't
Quest.
want to. Like, I want everything
I
either in
refuse.
Canvas and in the textbook.
I refuse.
Or that one website. That one website's
Do
really
you
nice.
select the little check marks in that?
The little check mark.
Yeah, you're right.
Actually, like,
No.
we like
This
do
is
these physics questions
unnecessarily
and ask you about
hard.
this
Yeah,
stuff,
like for
then
no
you don't
reason.
actually
Like,
see any of it on the test. You're like,
we
what was
don't
that
have
for?
questions. And
Supposed-
literally none of it's on the test. I swear.
They had one about temperature with the waves.
Yeah,
I
I
didn't
don't know how to do
I
that.
had to go look at the equation for
Yeah, I
what,
should
like,
never
the
thought
speed
of
of
that.
sound is at different temperatures. I was like, when am I going to need this until I get to college?
I think.
You're in college. That's what you need to understand. If
Well,
you're,
no, we don't even cover it. It's
Oh.
331 plus 0.6 times the temperature in Celsius, by the way.
yeah. Times Celsius or Kelvin?
Times Celsius.
Really? What kind of heresy is that? They need to fix their test.
I don't mean
I
that
think
there's
this is-
all of the.
Because that means it has a negative. If it's negative Celsius, it has a negative speed.
Could not say.
I think it's Celsius above, what was it, 0? It's only Celsius above 0, I think, or something like that.
Well, they could have
It's
rewritten their
0
formula.
Celsius is 3.
All right. We good here?
And it's not even the whole equation.
Wait,
It's like,
isn't it velocity?
no, it's the speed of sound.
All right.
I like this.
Two separate equations of equal concentrations. The first solution contains sodium hydroxide. The second contains barium hydroxide. Which of the following statements is true? Ooh, this is a fun one. Let's see if our contestant at home can win.
Dun, dun, dun,
Can you
dun,
see it?
dun, 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 dun.
Write your answers. Write your answers down. Write your answers down and see if you win a prize.
What's the prize?
Wait.
You're blocking the video? The first solution contains sodium hydroxide. They have equal concentrations. And the second contains barium. Which one has a lower pH, or are they equal since they have equal concentrations? All right, draw it out. Consider it training.
It says A or B.
Or C.
No, C.
Or F. Formula for sodium hydroxide's what?
NaOH. Oh, sodium or barium?
Sodium.
Okay.
Barium hydroxide is
BaOH2.
Oh, sneaky.
okay, BaOH2. So what's that mean when that dissociates? Are they both strong?
Yeah.
Yes.
Yes, they're both strong, so they're both going to dissociate completely. So this is going to do what? This is going to give me how many hydroxides?
1, but that one's going to get 2.
And this one's going to give me 2 hydroxides.
A little sneaky.
So which one's going to give me the lower pH?
That one would be the one with 1 hydroxide. Sodium
A.
hydroxide. Final answer. A.
A.
No, that's
Which one's going to give me the lower pH?
BaOH2.
I wasn't here for pH.
They're
A.
equal.
I don't really know.
Final answer. A.
No.
C.
Okay,
Well, if it's lower
let's
pH.
let's go through this. Who's going to give me the higher POH?
That one was there.
Oh.
Who's going to give me the high, the?
Barium
It's
hydroxide.
B.
It's B.
Oh.
Remember we started this class, I warned you about that thinking, right? Your hydrogen ion concentration is inverse to your pH. Barium hydroxide is going to have a lower, right? Lower pH.
Oh, this is confusing.
Wait, hold on.
So the strong.
No, it's not. Oh, the sodium. No, it's not B. It's
A.
A.
Oh
Yeah.
my god.
For the other reason. There we go.
I was like, this ain't. No,
Okay,
it's
but
not-
why?
Wait, hold on.
But the why? So barium's going to have a what? Barium's going to have a
Barium has more
lo-
hydroxide.
A higher hydroxide
So it's gonna have
concentration and a
less-
lower hydrogen concentration, meaning its pH is going to be
Yeah,
higher.
higher.
because of
Okay.
inverse
That.
volume.
So if that's the case, then I'm going to have a higher pH. There we go.
I was like, wait, hold on. Wait.
It's all because of our visitor. Isn't this more entertaining than Dance Moms?
Yes.
See, I think so. Good. There, I got.
What?
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 They're going to natural.
All right. What volume of water must be added to 100 milliliters of aqueous sodium hydroxide to change the pH from 12 to 11?
I'm guessing C. I don't really know.
What are we doing? If I'm moving pH, I'm moving in orders of what?
This is a strong base.
Why is it like
It's a strong base. That's going to make your life easy.
Yeah. I assume the answer is A. Or D.
Well, you're thinking. I mean, you're on the right track. Individual numbers of pH are what? Powers of 10, right? So how do I get, if I need to move from 100, I need to go from 100 to I need to go from 100 to 1,000. So how much do I need to add? 900.
Oh, 50.
I was close. I was close.
That makes sense.
I was on. I was.
This is a great question. If it wasn't a year dominated by crazy, I would probably I would probably give this question to my babies. So my babies next year, 9th graders, you're going to get this question.
9th grade.
So, because 9th graders this year, I'll see them next year. So, all right. That'll do it for today. We'll have some more fun and excitement for you next time. We'll probably have a quiz Monday. We will probably have a quiz Monday, so just be ready for that.
Is
A quiz.
That's like
she won't
not
be
one question can be answered.
Yes, she will.
Knowledge of the relationship between all of those. It's like, what happens when you increase one or decrease one?
So we have like 4 class days before the exam, so hopefully y'all are studying on your own.
Foundations of how linked.
We have like 4.
During Eagles Nest and grade the rest of my test.
Yeah.
Say
We have like 4 class periods before, 5 class periods before your test.
And my or the end.
Before AP test. Before the AP test, yeah.